Okay, we're on record. And we're going to talk about solving this example. I saw a couple people did give me the answers, and it looks like they're right. This is called an absolute value equation. Remember, these two straight lines on either side of the equation tell you that that's that symbol. It's called absolute value. And if you recall what we said to do when we want to solve it, is the first thing is to get the section that has this absolute value, that has to be all by itself on one side of the equation. So I have to get rid of this thing that's outside the absolute value sign, which is the -5. And since it's a -5, we'll get rid of it by adding 5 to both sides of our equation. So that's step number 1. Make sure you've isolated your absolute value. That's always your first step. If you don't have, if it isn't isolated, get it isolated. Get anything that's on the other side, on the side where the absolute value has to be on the other side. Well, now we've done that. We've isolated the absolute value. And here's what we have to remember. With an absolute value equation, you always are supposed to get 2 solutions. The way you solve an absolute value equation is after you have the absolute value by itself, you break it up into 2 different equations. One equation is 4x minus 9 equals 15. And the other equation is 4x minus 9 equals -15. You take this number that's on the other side of the equal sign, which has to be a positive number, and you set one equation by just dropping those absolute value signs, and you get the other equation by just changing this, giving the opposite sign, and then you have 2 equations that you have to solve. So let's do this one. We're going to do by adding 9 to both sides, which will give us 4x equals 15 plus 19, which is 24. And when I divide by 4, I get one answer, which is equal to 6. The other equation I get by adding 9 to both sides. Again, I'm adding 9 to both sides. But this time I'm going to get 4x equals -15 plus 9, which is -6. And I'll divide again by the 4. And this answer turns out to be a fraction. Now, how to write the answer to a fraction? So one way of writing the answer, which is probably the way you would get the answer on a multiple choice test, let's say this is being given on the midterm, they would reduce this answer. They do -6 divided by 4. You could divide the top and bottom by 2, so that'll give you -3 over 2 as your second answer. Or alternatively, you could have put it into your calculator, -6 divided by 4, and get -1.5. -1.5 and -3 over 2 are the same answer. Again, in a multiple choice example, they'll probably give the fractional version as the answer and not the decimal version. So they won't give you a choice where it would be this, be one answer and that'll be another answer. But don't forget, there are 2 answers, 6 and -1.5, or alternative 6 and -3/2. Does anybody have a question on this? Okay, I see a bunch of everybody, most people did get it right. That's excellent. All right, so I'm going to now talk about, I just want to finish up this section on different types of equations and inequalities. And I want to talk about number 1, now that most of you should have a calculator, I want to talk about what happens when you have a fraction, not when your answer comes out to be a fraction, but what if there's a fraction in the whole example? I'm going to show you what I think is the simplest way to handle equations with fractions. We've done equations that had decimals. Let's see how we could handle an equation with fractions. And the other thing I'd like to talk about is also some word problems, some applications of these type of situations. How do we set up a word problem? We're going to be, I know people find that word problems are one of the hardest parts of the course to deal with. So instead of my doing all the word problems in one shot, I like to intersperse the course with do it different times so it doesn't become overwhelming. So first, let me show you how I think you could handle an equation that has fractions in it. We're going to be actually doing a whole unit on working with fractions. And what I'm telling you now will apply there as well. That's why I want to do it now. I'm going to do simple ones now, and a little bit later we'll do some that are a little bit more complex. So let's say I gave you an equation that looks like this. X over 5 minus x plus 7 over 3 equals 1. This is a regular equation, a regular linear equation, except there are fractions in it. And the fractions tend to make the whole situation more difficult. So my first step, whenever I see fractions in equations, where some things are fractions and some things are not fractions, I make everything into a fraction. Any whole number, which is what we have over here, is number 1. Put that over 1. That way, it'll be easier for you to keep track what is the numerator, what's on top, and what's the denominator, what's on the bottom. So let's not try to do things that are mixed numbers, whole numbers, and fractions. If the question has fractions in them, let's just do it strictly fractions. The next thing I do is I find something called the LCD, the lowest common denominator. And basically, that is the number that all the other numbers go into. One way of finding the common denominator is to start with the biggest denominator, which is in this case is 5, and start multiplying. Okay, so we look at 5. Does the 3 divide into the 5? Obviously not. So let's try 5 times 2, which is 10. Does 3 divide into 10? No. So that's not going to work. So then I take the 5 and multiply it by the next number, which is 3. 5 times 3 is 15. Notice 3 will divide evenly into 15, and 1 will divide evenly into 15. So my LCD in this case happens to be 15. If you run into trouble and you can't figure out the LCD, you could just multiply all the denominators together. Notice if I did 5 times 3 times 1, I would have also gotten 15. Once you've decided what your least common denominator is, you're going to put that least common denominator, the 15, over 1, and you're going to multiply your whole equation, both sides, by the 15 over 1. You take your common denominator, put it over 1, and multiply your whole equation by that. Now we know when we're multiplying terms, we have to use the distributive property. So therefore, I'm going to take this 15 over 1 and multiply it by the x over 5 minus the 15. I'm putting it in green. I hope you can see that. So you can see that I'm distributing it. So I'm taking the 15 over 1 and multiplying it by the x plus 7 over 3. And finally, on the other side, I have to do the same thing. I have to take the 15 over 1 and multiply it by 1 over 1. I distribute my common denominator. Now, let me just remind you, because you could do this using your calculator, but it's probably easier not to. Basic rule in multiplying fractions. This is just an example. Suppose I have 8 over 3 times 9 over 4. What we can do, the basic rule in multiplying fractions is to multiply the two tops together and to multiply the two bottoms together. But if you can, you try to do something called cross canceling. Look if there's anything. I have this numerator of 8. Is there any denominator that could cancel out with the 8? And if you remember, yes, the 4 and the 8, I can go 4 into 8 and give me 2, and I can go 4 into 4 and give me 1. This is what's called cross canceling. Any numerator with any denominator. It can't be two numerators together. It can't be two denominators together. When we multiply, we first try to cross cancel. Now, can I do anything with this 9? Yes, there's a 3. So I can divide the 9 by 3 and give me 3, and the 3 by 3 and give me 1. And now when I go to multiply, I multiply the two numerators together, the 2 times 3, which gives me 6. And here I get the 1 times 1, and it gives me 1, which gives me my answer is 6 over 1. Usually when your answer has a denominator of 1, we just write it as 6. So this is, notice when we've not only multiplied the two fractions together, we've multiplied the fractions and reduced the answer to its simplest form. So look what happens over here. Let's go back to this. We have 3 different multiplications that we have to do. Here, the 15 and the 5, the 15 on top and the 5 on the bottom are going to cancel out. This will give me a 1, and this will give me a 3. And when I multiply it, now I multiply the tops together, 3 times x is 3x. And the denominator is 1 times 1, which is 1. Remember when I said when the denominator is 1, you really don't have to put it in. We're going to see, since we're multiplying by the common denominator, everything is going to cancel out. Let's go to the next thing. Over here, I have a 15 and a 3. I can cancel out the 3. 3 into 15 is 5. 3 into 3 is 1. And now I'm going to remember there's this minus here. I'm going to take the minus 5 and multiply it by the x plus 7. Now, this is negative 5 to multiply it by the whole x plus 7. And notice it's in the parentheses. And finally, over here, there's nothing that cancels out, so I just have 15 times 1. Again, the denominators are 1. So I have ended up where I started out with an equation that had a lot of fractions of them. I have an equation that doesn't have any fractions. It's just a regular equation. And we're going to finish solving this first by removing the parentheses, 3x minus 5x minus 35. Don't forget, we have to distribute that, equals 15. And I combine the like terms, the 3x and the minus 5x is negative 2x. And I just bring down this negative 35. I now add the 35 to both sides, so that I'm ending up with negative 2x equals 15 plus 35, which is 50. And I finish this by dividing both sides by negative 2, which gives me as my final answer negative 25. This preparation of multiplying everything by the common denominator, after I've done that step, makes it into a much simpler equation where I don't have to deal with fractions. So this is a method of dealing with any equation that has a fraction in it. Does anybody have a question? Okay, so I'm going to put another problem on the board. And I'm going to put one that specifically has a fraction on it. So to see if we could do this. Okay, is everybody okay if I erase this now?
Yeah.
Yeah, okay, good. Okay. So I'm going to erase this and I'm going to put in another problem. And guess what? I'm going to give you one that's a absolute value equation. So we'll get a double dose. Practice with a fraction and practice with a absolute value. So, and this actually, I have this off of an old midterm. So this is the type of question you might see in on a test. We have the absolute value of 2 minus 3 over 4x. Close that absolute value, minus 8 equals 12. Okay, while you're doing that, I'm gonna read attendance. Just make sure you let me know you're here. Jesus Antonio. Okay, great, you're here. Jackson, good. Let me see, you're here. Tiffany.
I'm here.
I see you're here. Kayla Brantley. Kayla. Tashana Caesar. Tashana, hi, Tashana. Oh, Kayla, you're there. Okay, great. And Tashana, you're here also? I'm pretty sure I saw you before. Yes. Okay, great. Dion, I know you're here. I've talked to you before. Wensley. I don't know if he was able to get on because he was the one he told me he had no power in his house. So I'm just going to write 9-2 excused. Certainly is excused for that reason. Tatiana Collins. Tatiana. Awa Diallo. Good morning. Ashay Douglas. Ashay, are you here? Ashay Douglas. Eliana Estee. Eliana?
Here.
Good morning. How are you?
I'm good. Good morning.
Christopher Fleming. Emily Gomez. Hi, Emily. Anastasia Guerra. Anastasia. Zanadu.
Here.
Good morning.
Good morning.
Ismail Hassan.
Here.
Good morning.
Good morning.
Jaden, I see you right there. I see your name right in front of me. Good morning. Ashiana.
Here.
Good morning.
Good morning.
Anijah John.
I'm here.
Good morning. Did I say your name right this time?
Yeah.
Thank you. Thomas John.
Yeah.
Good morning.
Good morning.
Paul LeBrun. Paul.
Here.
Good morning.
Good morning.
Ashley Moorhead. Angelica.
Here.
Angelica, you here?
Yes, here.
Good morning.
Good morning.
Tayon. Good morning. Akeem.
I'm here.
Good morning.
Good morning.
Craig Ricketts. Hi, Craig. Did you get my email that with the information you needed? Okay, good. Giovanni Rowe. Devonley here? Najay Kathy Waddell. Are you here? Jasmine Wood. Okay, I think we can start working on this example. And I see I have these two lines. So I see the first thing is that it's an absolute value equation. And before I do anything, I want to get that absolute value all by itself, which means I have to get rid of this 8. So I'm going to add 8 to both sides. So that'll give me the absolute value of 2 minus 3/4 x equals 12 plus 20, which 12 plus 8, which is 20. Now remember, whenever I get to this stage, when we're solving, I always look at this number. I have to make sure this number is a positive number. If it's a negative number, I stop right there. It can't be a solution. So if this would have turned out to be -4, for example, I wouldn't have had to do any work, so I wouldn't bother with the fractions or anything. But of course, in this case, it is a positive number, so I have to go on with my steps, which is to write my two different equations. It's 2 minus 3/4 over x equals 20 is one equation. And my second equation is 2 minus 3/4 x equals -20. And I want to use this method that I talked about before. There are other ways of doing this, but I just want to practice, use the method. I see fractions, I want to use the common denominator method. Now, in order to do that, I'm going to start with this one. I'm going to do this one way and this one the other way so that you can see the two alternative ways of approaching this problem. Both methods will give us the same answer. You'll use the method that you feel most comfortable with. In this case, I see there's a 4 in the denominator, so I'm going to make this a 1 and this a 1 so that everything's fractions. And the denominators I see are just 4 and 1, so that the LCD is going to be 4 times 1, which is just 4. I'm going to multiply this whole equation by 4 over 1. Now I'm going to have to distribute that 4 over 1. So I'll have 4 over 1 times 2 over 1 minus 4 over 1 times 3/4 x equals 4 over 1 times 20 over 1. I stick in this 4 over 1 next to each one of these terms, both sides of the equation. Now here, the first one is 4 over 1 times 2 over 1. There's nothing that's canceling out, so I just multiply the tops together. 4 times 2 is 8. The denominators, and we'll always see when our denominators will turn out to be 1. So I don't have to put in that one, and that first term becomes an 8. Now I go to the 4 over 1 times the 3 over 4, and now the 4 on top here cancels with the 4 on the bottom here. And I simply have -1 times 3, which is -3x. And finally, over here I have 4 over 1 times 20 over 1, which just nothing cancels out. I'm left with 80. Again, the fact that I multiply, even though this is a little bit of a difficult step, it makes the rest much simpler. I simply bring the 8 over here. So I get -3x equals 80 minus 8, which is 72. And I have to divide both sides by -3. And of course, I can use my calculator to do that division. 72 divided by 3 is 24. So this gives me that, I don't want to go too low, x equals -24. So my first answer to that was -24. When I go to do the other one, it's going to be almost the identical steps. Again, I'm going to put these whole numbers over 1. And whatever common denominator worked over here, it'll work over here as well. I'm going to multiply everything by 4 over 1 here as well, which will give me the 4 over 1 times 2 over 1 minus the 4 over 1 times 3/4 x equal the 4/1 times -20/1. Same exact thing that I had over here, the only difference being the minus here. And again, the answers are going to be the same. This is just going to give me the 8. Here, the 4s are going to cancel out. I'm going to get -3x. And over here, I'm going to get -80. In other words, whatever I had on this side as a positive over here will turn out to be a negative over here. So I really could have just taken this one and made that negative. And now I'm going to do -8 from both sides again, which will give me -3x equals -88. And I'll divide both sides by -3. And a negative over a negative gives me a positive. 88 is not divisible by 3. So I just leave my answer 88/3. I don't put it into a decimal. These are and this is the answer I would look for. Actually, those are the answers that came out on this multiple choice example. 24 and -24 and +88/3. What made this question a more difficult question? Simply the fact that there were fractions. The concept is the same. You get the absolute value by itself, and then you break it up into 2 equations. But again, anytime it involves fractions, there is going to be a little bit more difficulty. Okay. Let's talk about see if I can do something else with a fraction. Okay, let's go on to something new. We'll do some more of these. I'll probably assign some with fractions for homework so you can just practice. We will I'll reteach this whole concept of using a common denominator. I'll go over it several times because I know it's a little bit more difficult situation. Does anybody have any questions before I erase this? Okay. Today I'd like to talk about a couple of different types of word problems that we can set up equations for and that you are required to know how to do. One type of equation of question has something to do with what we call the perimeter of a rectangle. When we talk about the perimeter of something, we're talking about how long it is all around. Now, rectangle is a 4-sided figure where the 2 pairs of opposite sides are equal. This side equals this side, and this side equals this side. We call one side the length, and the other side we call the width. usually we call the longer side the length, but it could be the shortest side. It doesn't really matter. We just take, there are two sides that are equal. They're the lengths. There are two sides that are equal that are the width. If the length and the width are all the same size, then what we have is not a rectangle, but something called a square. A square has all four sides equal. Now, let's say I told you that the length of my rectangle is 8, and suppose I told you that the width of my rectangle is 5. I measured my rectangle, let's say it's my room. So I have a hallway, and I see it's a rectangular shape, and the hallway is 8 feet in length and 5 feet in width. And I want to figure out how much it's going to cost me to put a fence around this area. Let's not call it a hallway, let's call it a part of the bay. See, it's a garden. Let's say I have a garden here, and one side of the garden is 8 feet, and one side of the garden is 5 feet, and we want to fence in this garden. We want to know how much is it going to be all around. When I talk about enclosing something, let's say in a fence, we're talking about finding the perimeter of that rectangle. And perimeter, there are a couple of ways you could do it. I know this one is 8 and this one is 8 because I told you the length is 8. I also know that this is 5 and this is 5 because the width was 5. So one way of finding the perimeter is to add everything up. 8 plus 5, it's called P, the perimeter. 8 plus 5 plus 8 plus 5, which will give you 8 and 5 is 13. 13 and 8 is 21. 21 and 5 is 26. And the perimeter of this rectangle is 26, say it's feet. We could have also just done it by, there's a formula that says the perimeter is 2 times L plus 2 times W. I could have just multiplied the 8 by 2, and I could have multiplied the 5 by 2, and this would give me 16 plus 10, and again, it would give me 26. So either I could just add all 4 sides together, or I can multiply each of the length and the width by 2 and then add it. We will come up with the same answer, but basically the perimeter is the length all around, how much we need to enclose this figure. So let's look at a type of question that we might encounter with perimeters. Suppose I tell you that the perimeter, this is the swimming pool. The swimming pool has a perimeter of 100 meters. That means when I add up all the sides of the swimming pool, it added up to 100. We're told that the length is 12 meters more than the width. Find the dimensions of the pool. What are the dimensions of this pool? Okay, so first of all, I just introduced a new word. That word is dimensions. The dimensions of this original rectangle that I was talking about, this garden, are 8 by 5. To ask what the dimensions are is the same thing as asking what is the length and what is the width. When you're asked about the dimensions of a rectangle, they want you to figure out what is the length and what is the width. Now let me, so that's what they're asking. They're telling me what the perimeter is. Over here, I told you what the length and the width is, and I had to figure out the perimeter. Now we're doing the opposite. We're given the perimeter. Here's my rectangle. The whole perimeter of it is 100. It's 100 meters, but I'm just putting in the 100. And we want to figure out how long it is and how wide it is. And we're going to do this using an equation. And I have to see what they said. The length is 12 more than the width. In other words, we're starting with something called the width. And if we add 12 to it, we'll get the length. So when I'm going to call my width x. I don't know what it is, so I'm calling it x. The length then is 12 more. More means what are you doing with it? You're adding. So the length must be x plus 12. In other words, they're telling me what the length is in terms of the width. So I call the width the x, which gives me the length to be x plus 12. If it would have been 12 less, I would have done x minus 12. It's interesting, when I write 12 more than the width, I don't write 12, though there's nothing wrong with it. I usually don't write 12 plus x, I write x plus 12. I take the x, and if it's more, I add, and if it's less, I subtract. Now, in that case, this side, which is also width, is going to be x, and this side is going to be x plus 12. Because the two widths are the same, the two lengths are the same. That's what makes it a rectangle. So the perimeter in terms of x will be x plus 12 plus x plus 12. Those are the four sides. That's what the perimeter is. You add up all the sides. And I know that the perimeter is 100, so that's going to be equal to 100. So I've now gotten an equation that expresses the information from this word problem. Now all I have to do is solve that equation. X plus x plus x plus x. Those are the like terms, gives me 4x. 12 and 12 gives me 24. That's going to equal to 100. I subtract 24 from both sides, which gives me 4x equals 100 minus 24, which is 76. And then I have to divide both sides by 4. It's a regular equation. And 76 divided by 4 gives me 19. I'm using my calculator, which means that the x is 19. That's the width. And the length is x plus 12, which is now 19 plus 12, which is 31. So what are the dimensions of this pool? The dimensions are, you could say the length is 31 and the width is 19, or you could just say it's 31 by 19. Sometimes written this way, 31 by, with an x in between 19. Sometimes that's how the dimensions are given. It's 31 meters long and 19 meters wide. So that's how we solve any question that has a perimeter in it. Let me see if I can give you one to try on your own. I'm going to give you one that's a little bit more tricky. Let's see if you can come up with that one. Here's the information. the length of the rectangle is 5 less than the width. Let me make it a little higher. Five less than twice the width. The perimeter is 38. And I want you to find the dimensions. Okay, so the length is 5 less than twice the width on this rectangle, and its perimeter is 38, and I want you to find the dimensions. Let's see if you can do that. I'll give you a few minutes to try. If you get an answer, you can put it on the chat, or you can just say it. Okay. Does anybody want more time with this? So let's try and do this together. Again, we're talking about a rectangle. So here's my rectangle. And we know that the perimeter of this rectangle is 38. That we know. Because that's the last thing we were told. Right, they're also giving me information about what the length is in terms of the width. We're told that the length is 5 less than twice the width. So let's call our width x. Our x, we're going to call this our x. Since it's describing what the length is in terms of the width, we want to give we want to make sure that we call the width the x. Now let's go to this. How do I write in algebraic form that the length is 5 less than twice the width? Now twice is another way of saying 2 times. So it says that the length is 5 less, which means I'm going to be subtracting 5. Notice 5 less means subtract the 5 at the end from twice the width, from 2 times the width. So 2 times is another way of saying 2x. In other words, the length will be written as 2x minus 5. Be careful, don't do 5 minus 2x. When it says 5 less, it means that 5 is the number that's being subtracted. Well, doing it the way we did before, this will also be x, because that's the width, and this will also be 2x minus 5. And now I add them all up. X plus 2x minus 5 plus x plus 2x minus 5. That will give me the whole perimeter, which is 38. When I combine the like terms as x and 2x is 3x, 4x, 6x, I get 6x. And negative 5 and negative 5 is negative 10 equals 38. It's now a regular equation. I add 10 to both sides. That gives me 6x equals 48. Divide by 6, and I get x equal to 8. So my width is 8. But remember, it asks for the dimensions. The dimensions is not just the width, it's also the length. The length we do 2 times x. Well, now we know the x is 8 minus 5. So that's 16 minus 5, which is 11. So my length is 11. My width is 8. I could write the dimensions are 11 by 8. That's what the answer to this problem would come out to be. And this is about as difficult a one as you're going to get. Remember that if it says there's a number in front of here, if it would have said 3 times the width, you would have done 3x. But don't forget, when it says 5 more, you add 5 to the end. If it says 5 less, you will subtract 5 from the end. And again, the perimeter is all the 4 sides added. This pretty much takes us to the end of chapter 1. Chapter 1, we covered linear equations, which was a review. We did linear inequalities, how to solve inequalities also. Okay. You want me to do one now, or should I leave it for next time?
You could do one now, please.
Okay. So let's do one more like this. I'll give you one more to do. Can I erase what's on the board?
Yes.
Yeah, okay. So we've done so far linear inequalities, where we learned how to put them on the number line and an interval notation. We did absolute value equations, and we did this solving a perimeter equation. Here's another example. Okay, the width of a rectangle, well, let's just call it the width. Is 5 less than the length. The perimeter is 70. Okay, and I want you to find the dimensions of that rectangle. Give you a couple minutes to try that. Okay, I see somebody has the answers. Let's see if that's correct, Shauna. Here's my rectangle. Now we're told that the width is 5 lengths less than the length. So they're telling us what the width is in terms of the length. The first thing we're starting with is the length. So let's call that length the x. And the width is 5 less, means it's x minus 5. This is once you get this part right, the rest is really easy. Expressing your two sides, always one's going to be x and the other one's going to be in terms of the x. Don't forget again, if it's more, you put the number at the end and add it. If it's less, you subtract that number at the end. Just like here, 5 less is x minus 5. We're taking away the 5 from the x. And of course, and this is also x minus 5, and this is also x. So my perimeter is x minus 5 plus x minus 5 plus x. Those are the 4 sides added up, and they add up to 70. And now I add up the like terms. This is 1, 2, 3, 4x. Negative 5 and negative 5 is minus 10. So 4x minus 10 is 70. If I add 10 to both sides, I get 4x equals 80. So it turns out that x equals to 80 divided by 4, which is 20. So this is my 20, my x, that's my length. And the x minus 5, which is the width, is 20 minus 5, or 15, which is, trying to think, this is exactly what we did get as, yeah, 15. Thank you to Shauna. That was perfect. 20 by 15 is the dimensions of this. And again, you could write the dimensions separately as the length is 20 and the width is 15, or you could just say 20 by 15. Does that help you? I'm trying to think, who asked me the question?
It was me, a little bit,
Is it better now?
a little bit. I'll keep practicing.
Okay. Again, we'll go over this next time. Remember, our next session is not the Tuesday, but it's next Thursday. But there probably will be homework on Delta Math. Now, I did want to get a little bit of a start on chapter 2, just to give you a taste of what we're going to be doing next. And that has to do with what's called graphs of equations. We're going to be starting a chapter that has to do with graphing on graph paper. Now, I don't have a graph board, so I'm going to have to do things pretty much freehand. But I suggest that you get yourself a package of graph paper and try these problems that we're doing on graph paper. When you see the thing worked out on graph paper, it looks much more clear than just doing it on loose leaf. If you want exact answers, then the way to get exact answers is to actually do this on graph paper. I just want to remind you how we graph on what's called the Cartesian coordinate system, this graphing system that we use in mathematics. What we're going to do is we're going to graph in 2 dimensions. We're going to have a horizontal line, which we call the x-axis. And then we're going to have a line going up and down, a vertical line, which we're going to call the y-axis. I'm sure you've all seen this before. The point where they meet is what we call the origin. And the coordinates, every single point on this, my whole plane, on my whole flat surface, is going to have 2 numbers associated with it. One number is going to be what we call the x coordinate, the x number, which tells you, if you're starting the origin, how far to go right or left. When we've done this on a number line, it's just like a regular number line, except there's going to be a number line horizontally and a number line vertically. So the first coordinate, the first number you're going to see, is going to tell you whether to go left or right and how much. If it's positive, you go to the right. If it's negative, you go to the left. The second coordinate, the second number, is the number that tells you how much to go up or down. Again, if it's positive, you go up. If it's negative, you go down. So if I have something that looks like this, -3, 2, this is called an ordered pair of numbers. It represents a point. So I will very often call the point -3, 2. Now you're going to say that's not a point, that's 2 numbers. But in our system, in our graphing system, every pair of 2 numbers will represent a single point. And we'll always put these numbers in a parentheses so you know that what we're talking about is a point. Where is this point -3, 2? Well, it means start at my origin. First number is the x coordinate, means -3, go 3 to the left. And the y coordinate, the y number is 2. That means from the here, go up 2. And this is the point -3, 2. Notice I have to do 2 steps. I have to do the sideways step, and then I have to do the up and down step to get to the one point that is the point -3, 2. Vice versa. If I give you a point, let's say I gave you this point over here. And I said, I want to know the coordinates of that point. When I say I want the coordinates, I want the 2 numbers associated with it. So the first thing I have to do is start at the origin and see how much right or left I have to go. And if you notice, I have to go 1 unit to the left to get over here. So the x coordinate is -1. I also have to go, aside from going left 1, I have to go down 1, 2, 3, 4 down, so that my y coordinate is -4. So this is the point -1, -4. The origin itself has the coordinates 0, 0, because if you're on the origin, you're not going left or right, you're not going up or down. So every single point on the plane has 2 numbers associated with it, its coordinates, and every pair of coordinates represents a single number. You don't need to buy the textbook. I'm just answering Ismail's question. It has a lot of good problems in it. It has a lot of good work in it. Mostly I give you work on Delta Math, and I cover the work in class. It's certainly a good reference book. It's an excellent book, and it's not expensive. So it is a good idea to buy the book, but if you don't, you can certainly get through the course without doing the book. About the group chat, that is, I didn't have anything to do with the group chat, but I did enable you to to email each other. I opened up the tools unit on the Blackboard, so you can email each other and get in touch that way. Okay, great. All right, so this is the basics of graphing when it comes to points. Now, when it comes to other types of figures, we don't have just numbers, we have equations. And we're going to learn, or right now, review how to graph the equation of a line, how to graph a linear equation. It turns out we'll know that we have a linear equation when we don't have any x squareds or y squareds. It's just plain x's and y's in our equation. For example, suppose I gave you an equation that looks like this. 3x plus 2y equals 6. Now, this is an example of a linear equation. This is an equation that has x's and y's. We're going to need x's and y's on this set of, because there are going to be two variables. There's going to be the x number that'll tell you whether to go right or left, and there'll be the y number that'll tell you to go up and down. It's a linear equation because it doesn't have any exponents. It's just a plain 3x, it's just a plain 2y. Anytime you have what's called a first degree equation, an equation that only has an exponent of 1 on the variables, which means there's not going to be any exponents, because if there's no exponents written, it means the exponent is 1. That's called a first degree equation. That's going to be a linear equation. It's going to give you the graph of a straight line. So how do we go from this equation of a line to the graph of a line? So I'm going to show you two different ways. There are actually there are three. I can think of 3 different ways that'll work. I'll show you 2 ways that make sense, and then I'm going to show you my favorite method, and that's what we're going to talk about. The first method I can use is called plotting point. I know this is going to represent a line. If I can find the points on the line, I could plot them on my graph and connect them. Okay, I'm going to erase some of these things that I wrote over here so that we'll have a free graph board. Okay, here's my graph board. So how do I find points on the line? How do we find the points on any equation? What is the connection between the equation and the points on the graph? And that is any point that fits into the graph, that fits into the equation, will be on the graph. So what I can do is just arbitrarily pick a value for x. Let's say I pick x to be 0. Solve the equation to find y. And I can have, then that will give me a point on the graph. I picked 0 because 0 is usually an easy number to work with. If I pick x to be 0, it'll be 3 times 0 plus 2y equals 6. Now obviously, 3 times 0 is 0. So this becomes 0 plus 2y equals 6. And of course, that's just 2y equals 6. And that gives me y equaling 3. In other words, a point on one of the points on this graph is the point x is 0, y is 3. Anytime I pick arbitrarily, I can pick a number for x and put it into the equation, solve for y, and that'll give me a point on the graph. Well, let's plot this point, 0, 3. When the x is 0 and the y is 3. So that means start at the origin. I don't go right or left because the x is 0, but I go up 3. 1, 2, 3. Here's my point 0, 3. That's one of the points on this line. It happens to be on the y-axis, so it's called the y-intercept. The point where the line crosses the y-axis is the y-intercept. We have 1 point, but you need at least 2 points in order to draw the line. So let's pick another value for x. Let's say I picked x equal to 2. I'm picking these numbers arbitrarily. So I picked x to be 2. Let's see what happens when I pick x to be 2. Then I get 3 times 2 plus 2y equals 6. Now here, 3 times 2 is 6. So I get 6 plus 2y equals 6. And lo and behold, I get 2y equals 0. And of course, if 2y equals 0, that means that the y equals 0. So another point on this line is the point x is 2, y is 0. So here, x is 2, 1, 2, y is 0. It happens to be a point on the x-axis. Actually, this would be called the x-intercept. Now, since I have the 2 points here, I can connect them with a line. And notice I draw the line longer, and here is my line. So one way of drawing the line is to figure out some points on the line by picking any number you want for x, sticking it into the equation, solving the equation for y, and those 2 numbers will be the coordinates of a point. I happen to have gotten lucky because I got easy numbers. This is 2, 0. I really want to show you a different method. So this is the plotting point method, and it happens to be a good method, but I'm going to show you a method that I really prefer to use. And that's where we're going to be talking about next time. Okay, I'm erasing this, and I'm starting with the exact same equation. 3x plus 2y equals 6. Now, this is a linear equation. It's called the standard format of the equation. The standard format of the equation is when the equation has the x's and y's on one side and a number on the other side. That's the standard format. The format that makes it really easier to graph is something called the slope-intercept format of the line. What we sometimes you might have heard it called the y equals mx plus b form of the line. Let me show you what that means and how we can use it. We take this original equation, 3x plus 2y equaling 6, and solve for y. In other words, we think of y as our variable that we're looking for, and everything else we treat as if we would do whatever it is to numbers. So I want to get the y alone. I'm solving for y. So the first thing I want to do is get rid of this 3x. So it's a positive 3x. I'm going to do minus 3x from both sides. Now that's going to get rid of the 3x, and I'm going to be left with 2y. Over here, I have a 6 and a negative 3x. Those are not like terms. They can't be combined because this one has an x and this one doesn't. And when we write it, it doesn't matter if you put the 6 first and the negative 3x second, but to get it in the format that we want, we're going to first put the negative 3x, and then we're going to do the plus 6. We want to have the x term first and the number without any x second. I still have another step to do. I have to get the y alone, which means I have to divide by 2, which means I have to divide every single term by 2. The whole equation is being divided by 2. And that gives me, well, here the 2's cancel out, y equals negative 3 halves x. And 6 divided by 2 is 3. When I have y equals, this is what's called the slope-intercept form. It's the exact same equation in a different format. And there are two important numbers that we can see here. One is what we call the m, which is the slope. The slope is the number or coefficient right in front of the x, -3/2. The second number is what we call the b, is the y-intercept. That's the number that stands alone, which in this case is 3. If I have those two pieces of information, I can graph my line. Here's my line. I'm doing it over here. When I have my line, I don't have to plot any points. I first go, if I have I put it in the slope-intercept form in the y equals mx plus b form, and I look at the b. The b in this case is 3. Remember what I told you the b stands for? It's the y-intercept. That means it's where the line is crossing the y-axis. So that's the first thing I do. I go to the y-intercept. In this case, it's 3. That's 1 point on my line. If you noticed before, that's exactly what we got. We did get that the y was, when the x was 0, the y was 3. That is the y-intercept. How do we get to other points? I need at least one more point in order to draw this line, because the line could go any which way from here. So that's where the slope comes in. Sometimes we call the slope the rise over the run. The slope tells you how to get from one point on the graph to another. That's what the slope tells you. It tells you how much the line is slanted, and it really gives you a direction and how to get from one point on the graph to another. So in this case, my rise over run is -3/2. Now notice my slope, let me just make a comment about it. The slope was a negative number. It was -3/2. When I have a negative fraction, I can either write the negative with the top, or I could write it with the bottom. There's one negative there, so it either can go on top or in the bottom. I usually keep it with the top. So when I say rise over run, and I tell you my rise over run is -3/2, it means rise, that means go up or down, -3. Now, a -3 rise really means go down, because a negative means going in the opposite direction. So for this, we have to go down 3, 1, 2, 3. And the run is 2. The run tells you how much to go left or right. The run is 2. It's a positive 2. It means then go 2 to the right to get to another point. And I could do this a second time. I could again do rise -3, go down 3, go 2 to the right. I could do this 100 times if I wanted to, and I'd keep getting different points on the graph. In fact, if I had looked at this as +3 over -2, I could have started here and risen 3, which means go up 3, but then 2 to run -2 means go 2 to the left. And notice that all lines up, and here's my line. This is my favorite method, what's called the rise over run method. And we're going to be talking next time more about slope and more about these things. Again, this is where we're going to be taking up and continuing on next Thursday. Again, look out for a another Delta Math. There are so far 2. I'm gonna probably put a third one on. Again, as long as by the end of the term you have done the assignments, you get your homework credit. We'll talk about tests a little bit later. Does anybody have anything they want to ask me before class is over?
Do we need to buy the textbook?
Here's my feeling. The textbook is a good source for extra problems, for information. I actually will probably not assign you anything specifically from the textbook. So if you don't buy the textbook and you're not having any trouble, you're fine without it. You must have a 2-line scientific calculator. That's a must, but the textbook I'm leaving optional.
Not a graphic calculator?
You're not supposed to be using a graphing calculator in this class. You're supposed to be using a 2-line scientific calculator.
All right, thank you.
Okay. I can't emphasize this enough. Make sure you read what's been posted on your Blackboard account, because that gives you, I mean, people have been emailing me, what is the code for getting into the Delta Math? When do we meet? When don't we meet, etc. All those things are answered on the Blackboard account. And on top of that, it gives you the schedule. It gives you, there's the academic calendar is there, this each week what's being taught, and there's always an example sheet for that week's lessons that will tell you the type of questions you are required to know. Look at spend some time as part of your homework going over your Blackboard account and seeing what's in it. If there's something that you see as a download, open it up, see what it is. There are exercise sheets with answer keys for each chapter that we do, so that you can know whether you have actually accomplished the work that you're, and of course, don't forget to do your Delta Math homework. Everybody okay with that?
Yeah,